action, drama, excitement. Project Aqua, only on HootieStyleChannel.
HootieStyleChannel. HootieStyleChannel.
I am back. Hey, and welcome back to HootieStyleChannel. First of all, press a like for the mustache. And if you hate it, press like anyway. I want to start out talking shortly about something absolutely amazing. We have reached 400 subscribers in less than a year, and that's just awesome. I know comparing this to the big channels on YouTube, it doesn't sound like much, but let me show you a picture. This is a picture of 400 people. Okay, maybe not, but this auditorium actually has 400 seats. That's all of you in there watching HootieStyleChannel. In fact, if we were to fly somewhere all together, you would fill a Boeing 777-300, and some of you would even get denied boarding because of the lack of seats. I'm just trying to say that we appreciate every single one of you fun individuals. Thanks for making this journey with us. Now, it's time we start talking about the next big thing here on HootieStyleChannel. And it's called Project Aqua. Yeah, I couldn't come up with a better name, but I promise the actual project is far more exciting. And don't worry, like I've said before, Project Elizabeth will always be around, and we're already working on an episode about the magicmirrorconfig.js, the internal module notifications, and how to use those to flip the mirror views with MMM pages, etc. So if you haven't subscribed yet, you know what to do. Okay, so Project Aqua. If you've been following us, then you've already seen a sneak peek of this aquarium project. But let's give it a proper intro today, and then we'll get more in depth for each episode. Project Aqua is going to be a freshwater, scaped, planted aquarium with a focus on the South American biotope. A biotope is best described as a geographic habitat, a term not exclusive to aquariums. For example, in an Amazonian biotope, the environment, the plants, and the animals are all from the Amazon area. You don't put a panda in there, if you know what I mean. And as you can imagine, you can become an absolute purist that won't even accept the soil to have the wrong composition, or you could just try your best to achieve something close to the real environment you're seeking. Our attempt will probably not be a pure biotope, but South America will be our direction, slightly. If you're a purist and want to hate on something, make sure to like and subscribe. Now hold on a minute. Isn't this a tech channel? Well, not really. This is HootieStyleChannel, where anything Hootie goes. But tech is pretty much central to anything Hoot. So let me explain where this project becomes overly complicated. The walls around the aquarium, unfortunately, painted with a water-sensitive paint. Super practical to have 200 liters of water next to the wall then, eh? We need a barrier to protect the wall. So I'm going to build one that can house the hoses, cables, and whatnot for a clean look. And on the short side, I'm going to leave more distance to the wall to hopefully prevent short diagonal splashes to reach the unprotected wall behind the sofa. As you can see, this solution is killing a lot of volume on the short side, and it would be a shame to let that space go to waste. So I decided to design and build a vertical drawer inside the barrier. And it wouldn't be a Hootie-style project if it didn't involve some type of gadget geekery. The drawer will move in 2 axes in 3 different phases. So in phase 1, the top of the drawer will move away from the wall, like just a centimeter or 2. That's half an inch to a maximum 1 inch before the next phase. The reason for this movement is that no wall is 100% flat. And when the drawer is closed, the top of the drawer sits just millimeters away from the wall. It's actually kissing the wall. If the drawer moved vertically at this point, then the irregularities of the wall could cause friction and we'd end up with a scratched up wall. So we move away from the irregular surface first, and then in phase 2, the drawer will move up. So it will start revealing the shelves inside. Lastly, in phase 3, the lid will open vertically to fully expose the drawer. All of this will be controlled by an Arduino board. Now let's look closer at each phase. For the first phase, I will be using a stepper motor of the NEMA 17 variety. NEMA, I don't know. A stepper motor is an electrical motor that's perfect for precise applications. It achieves this through electromagnetic positioning. I think this simplified animation from Wikipedia illustrates nicely how things work. The motor practically contains a rotor made of iron, surrounded by several electromagnetic coils, both with teeth. By alternating the active coils, the rotor will move to align its teeth with the teeth of the active coil, so it will step forward or backward. This means that if you move 10 steps forward and then 10 steps back, you will be back at the position you started. It might sound very elemental, but the truth is without the stepping, it wouldn't be so easily possible to end up where you actually started, unless you have a feedback system, but let's not get into that right now. I'm going to attach a cog wheel or a pinion to the shaft of the stepper motor and a rack to the top of the drawer, and in this way get the top to move away from the wall. In phase 2, the drawer needs to be pushed up. Here I'm going to use a linear motor or a linear actuator. This is practically a DC motor that is connected to a large screw rod through a gearbox. So when the motor moves, the screw rod will push on the nut connected to the arm, which will move up or down depending on the direction the motor is spinning. The gearbox becomes one of the decisive factors in the strength and speed of the linear actuator. More torque means less speed and vice versa. So finding the right specification for your application can be challenging because both fast and strong results in pretty expensive stuff. The one I have for this project is rated about 150 Newton, which is a bit shy of 15 kilograms. I don't know how many pounds that is, so just Google it or move to another country. I don't see any other solution. So about 15 kilograms of pushing force. The speed is rated at about 4.5 centimeters per second, but that is without any load. So once you put weight on it, it will slow down. To avoid getting a painfully slow lift, I'm going to cheat just slightly. The drawer with the top and lid will weigh around 5 kilograms. This is the weight this linear actuator will have to push together with the weight of whatever will store inside the drawer. I'm going to offload this weight as much as possible with a gas shock. By doing this, the linear actuator will move more freely and at an optimum speed. This is a Hootie style solution to an otherwise more expensive product, so don't forget where you saw this first. And finally, in phase 3, I'm going to use another linear motor, but this time a smarter version with a feedback system. You see, the linear motor used in phase 2 is a pretty dumb one. It will move up or down depending on the polarity and stop at the end positions thanks to built-in Hall sensors. However, you will never know at what position the arm is located unless you have external sensors presenting you with that information. Concisely put, there is no internal feedback in the linear actuator used in phase 2. This one is different though. There are built-in sensors in this one and we can get a real-time reading of the arm's position. This is important because in phase 3, I want the lid to open to a certain degree and not further than that. Like I mentioned, we're going to control all of this with an Arduino board, and we'll also use some external Hall sensors to make sure that all movements are going as planned. Hall sensors can be described as some type of proximity sensors triggered by magnets, and we will incorporate these small sensors on different locations in the build. It will make it possible to know, for example, that the top has moved away from the wall before proceeding to phase 2, or that the drawer has reached a certain height before the lid starts opening in phase 3.
Action, drama, excitement. Project Aqua, only on HootieStyleChannel.
I really hope I have ignited the nerd in you. Of course, we will also cover the actual aquarium stuff, aquascaping, planting, basic water chemistry, and naturally all the gadgets used to make the fish and plants thrive. I'm not sure you guys can tell, but I'm super hyped about this project. Anyway, this is HootieStyleChannel. I'll be seeing you in the next episode.